In this set of videos, we're going to look at how the unit circle relates to the six trigonometric functions. So first, a unit circle is just a circle with radius 1 and with its center at 0, 0. So the equation is x squared plus y squared equals 1. What happens in the unit circle, because the radius is 1, the arc length, so don't forget s is your arc length, which is the radius times the angle, becomes 1 times the angle, which is just the angle. So the arc length and the angle are actually the same, obviously different units, but the same number in the unit circle. And what we're going to do here is we're just going to use t instead of theta, just to make it a little bit more consistent with what we typically see for unit circle. So let's say t is that central angle. Then what happens is the angle t is the same as the arc length t. Here our radius is 1. Don't forget it's a unit circle, so we're going out to the number 1 here. Again, this would be 1 as well, so our radius is always 1. And the other thing you'll often see as well is they will put that point, which occurs on the circle, at the end of the terminal side. And there's some point there, x, y, whatever that point is, but it is on the circle, and it's where that angle ends. It's on that terminal side. And what happens is we use the unit circle to define the 6 trigonometric functions. The word trigonometry actually talks about the measure of triangles. So when you're creating these using the unit circle, you're actually creating lots of little triangles. You can kind of see it here almost, right, with that angle, that you're kind of getting a little triangle in a way. They come from really the unit circle. So here, just for some abbreviations, sine we write as sin, cosine is cos, tangent tan, cosecant is csc, secant is sec, and cotangent is cot. So oftentimes we will just write these instead. We won't actually write out the full word, but those are your 6 trigonometric functions. So on the unit circle, so let's say that angle is t here. Instead of using theta, we'll use t. And that point P is on that unit circle, again, on that terminal side. Then we can find the sine of the angle by just giving the y value of the point. Cosine is the x value. And then tangent is the ratio of the two. Tangent is sine over cosine. So it's y over x. For cosecant, it's really sort of the opposite of sine. So you're taking the reciprocal, 1 over y. Secant would be the opposite or reciprocal of cosine, so 1 over x. And then cotangent is the opposite or reciprocal of tangent, so x over y. So this is cosine over sine instead. So let's actually do an example so you can see how this all works. So let t be a real number equal to the length, of the intercepted arc of an angle that measures t radians. And again, we're typically in radians when we're talking about trigonometric functions as well here. So again, you really want to get used to working with radians in those upper level math classes. And our point here is going to be specifically -1/2 and square root of 3 over 2. And this is a point on the unit circle. That corresponds to that angle T. And what we're going to do is we're going to use this figure. I'm going to draw it for you in a second, to find the values of the 6 trigonometric functions at t. All right, so the first part is really kind of confusing to read it, but all they're saying is this. So you have a unit circle. All right, so let's draw that first. Okay, so again, the radius here is going to be 1. So we're going to be 1 here. I don't know the exact length of the angle. I just know it's T. So I'm going to just maybe call this over here the terminal side. Okay, so it's going from here to here and it's angle T. And I do know this point though, which is -1/2 cubed root of 3 over 2. So I do have to think about a little bit because my x value is negative. I do want it on this side, right? It should be on this side of the graph. Positive x's are here, negatives are there, and my y is positive. So I know it's somewhere in the second quadrant. I don't know exactly kind of how far that angle is, but I know it's somewhere over there. So that is our general picture. And again, this is the unit circle. So this is the x value 1. So you have the 0.10 there. And this would be the 0.01 and so on. So this is what the picture is. So we're going to just, don't overthink this. Your x value here for that point is -1/2, and your y value is the cubed root of 3 over 2. So if I want to find sine of t, again, so here's my angle t, which corresponds to this terminal side and that specific point, it's just the y value. And we're done. If I want to find cosine of t, it's just the x value, -1/2. If I want to find tangent of t, it's going to be y over x. So we have a little bit of work here to do. So it's going to be cubed root of 3 over 2 over -1/2. So what I can do here, I could actually multiply by -2 over 1. That would allow me to cancel that denominator. And then here I would have -2 root 3 or 2, or just -3. So you do want to simplify a little bit. Sometimes you may have a little bit of work there. So the next one we would have is cosecant. Apologies. Which is 1 over y. So 1 over y would be 1 over the cubed root of 3 over 2. So here you do a little bit of work. You're going to want to flip this. You multiply it by 2 root 3 to cancel it in the bottom. And then 1 times 2 root 3 is just 2 over root 3. We don't like to have roots in the denominator though, so we're going to rationalize this root. And to do that, we're going to multiply it by root 3 over root 3. So I'm multiplying it by root 3 over root 3 because that's the value of 1. It's not going to change the problem. But what happens is when you multiply a root by itself, a square root, it cancels out, right? Because it's because square root of 9, which is just 3. And then next I have secant, which is 1 over x. So that's 1 over -1/2. And again, you're just using the reciprocal here to get rid of that denominator. So 1 times -2 over 1 is just -2. And then finally, I have cotangent. Which is x over y. My x value here we said was -1/2. And my y value here is root 3 over 2. So I'm going to multiply by 2 over root 3, which basically takes it from the denominator and brings it up top. So here my 2's are going to cancel. So I have -1 over root 3. And now I do have to rationalize this. So I'm going to multiply by root 3 over root 3. So I have negative root 3 for square root of 9, which is negative root 3 over 3. And those are my 6 trigonometric functions. So a little bit of algebra here sometimes, but the actual work of it is pretty quick, right? So as long as you know that point, that is on the terminal side of your angle, that point on the unit circle, then we can just use the x and y value there to find what the 6 trigonometric functions would be for that specific angle. Again, it's just for that one angle here. So we're looking at one specific case. Let's do another example. So we're going to find the values of the 6 trigonometric functions at t equals pi over 2. Now remember, we're using t for our theta here. So t is your angle. So this is your angle. So they're not giving us the point here. They're actually giving us the angle. And you're often leaving out the words radians, but you should assume that it's radians unless it says degrees or gives that symbol. But if you start seeing pi's and things, it's in radians. So again, we're working with radians most of the time when we're talking about using trig. So here, I don't have the point, which is what I need to answer this question. So I'm going to draw the picture. And you want to remember that you're working with the unit circle. So in all these cases, it's the unit circle, meaning your radius is 1. So this is the point 1, 0. This would be 0, 1, negative 1, 0, and 0, negative 1. So your radius is 1. So keep that in mind. If you have to draw your own picture, it's always going to be the unit circle for the trig functions. And now I have an angle of pi over 2. So think back a couple videos. We know this one. This is one that we should be familiar with. And again, we always start on the x-axis, the positive side. Pi over 2 corresponds to 90 degrees, which is that quarter rotation. So it goes from here to here. So this is your t. So on our terminal side then, that is the point that we're looking for. It's always the terminal. So on the unit circle, our point, our p equals xy, so there should be an equal sign, is 0, 1. So our x value is 0 and our y value is 1. So you may have to find the point sometimes yourself, but you should be able to do that by finding the angle. So you can use what we've already learned. So again, sine of t here, or we know the angle, so you may see it written as sine of pi over 2, but actually put the angle in, is your y value, so it's 1. Cosine of t, or cosine of pi over 2, is your x, which is 0. And tangent of t, or in this case, tangent of specifically pi over 2, is y over x, which is 1 over 0. Now, this is undefined, right? We cannot divide by 0. So in this case, tangent doesn't exist. You can't have tangent of pi over 2. So at this specific point, again, there's other angles that we can look at, of course, but at this one angle, tangent does not exist there. So for cosecant of pi over 2, that's 1 over y, which is 1 over 1 or 1. For secant of pi over 2, that's 1 over x, which is 1 over 0. So again, this here is undefined. Secant of pi over 2 would not exist in this case. And then for the last one, cotangent of pi over 2 is going to be x over y, which is 0 over 1 or 0. Okay, so you can actually find the trigonometric values pretty quickly once you have your angle set up and you have that point on the terminal side. So I do always recommend drawing that picture to help you and just visualize what's happening.